In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum, my lovely students. How are you all? I hope you all are well and staying at home, safe and sound. I welcome you in Pakistan International School Types Virtual Learning System. This is class of science for grade 7 and we are on chapter number 6. Today we will see our last topic, molecules and chemical formula and law of constant composition. Dear students, let's start. Yes, students. In the previous topics, as you know, we have studied about atom, yes, its atomic number, atomic mass, some shells, how atoms combine with one another. Yes, we have seen about valency and ions also, cations and anions. We have seen some isotopes and its uses also. Today we will see a molecule. Dear students, as you have read in grade 6 and in the previous topic, we have seen when a molecule is formed when atoms are combined. So because most of the atoms are unstable and when they combine, they form a molecule. So a molecule is the smallest particle in a chemical element or compound that can exist independently and has chemical properties of that element or compound in it. Yes, the molecules. No, because the atoms are combined together and they form a molecule now, they are independently exist or they can move independently now because now they are stable and no other atom can combined with that until some requirements are given to them, like high temperature, energy, electricity, pressure, etc. Lots of things are there which will just change their conditions. So the atoms, molecules can be broken down and just combined with other atoms. So the molecule is having all the chemical properties of that element in there. The elements not the same, that can be different as well. So we can see here oxygen and compound, oxygen and carbon monoxide. So two oxygen, you can see O, 2O. So this is 2 here, it means 2 oxygens. And carbon, 1 carbon and 1 oxygen is there. That's why it's called mono. Mono means 1. Oxide, carbon monoxide. So carbon and oxide is here, oxygen and oxygen here. Both of the molecules of different elements are here is the same elements. They combine and they form a molecule by chemical bonds. So we are having some types of molecules as well. Some are elemental molecules and some are compound molecules. How we can see the element molecule and compound molecule? So if we see when the atoms are same, elements are same, and they combine together, they are called element molecule because they form element now. Oxygen, it is although a gas, but O, we don't say O is oxygen, we say O2 oxygen. So they form, they combine, O and O combine because they are same. And they form element now like that, fluorine, chlorine, bromine, iodine. But here also chlorine, bromine, iodine, etc. And you can see the sizes of the atoms because they are bigger atoms, because they are bigger shell, more shells in that, more electrons, more protons, so that's why they are bigger. So the compound molecule in which different atoms combine together in different ratios. Like in water, 2H and 1 oxygen is combined. In ammonia, 3 hydrogen and 1 nitrogen is combined. Carbon dioxide, 1 carbon and 2 oxygen are combined. That's why we write di for 2 oxide means oxygen. And methane, 1 carbon and 4 hydrogen are. So all these atoms are different. N is different, hydrogen are 3, but N is also with the N hydrogen are making the bonds, so they are different, so they are making compounds. Now we see that a molecule are having other types also that may be monoatomic molecule. Mono means one, so a molecule composed of just one atom, and they are not more than noble gases we have seen before, because they are inert. Inert means they cannot react with any other substance, any other atom. That's why they are called inert gases, because their outer shell is filled with electrons. They do not have capacity to just accommodate any other electron. They're called monatomic, means just one atom forms whole of the element, like helium, lithium, krypton, argon, xenon, and radon. Now I see diatomic. Di means two, atomic means atoms. In this molecule, two atoms combined together. They can be same or they can be different. So a molecule composed of two atoms of same or different chemical elements. For example, in H2, this hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas, iodine, bromine. So they are diatomic, means two atoms, O and O, they combine and they form diatomic, means two atoms are there. If we see the next type, that is polyatomic molecule. A molecule having many of the atoms, same or different elements. For example, in water, in glucose, you can see water. Poly means more. So they don't have one or two atoms, they are having more than two atoms. O and two hydrogen, that is H2 and O. And this is glucose. You see glucose? That is C6H12O6. This is hydrogen. You see hydrogen is the smallest atom, then carbon, and then oxygen. The size is according to their number of protons and electrons and the shells in that atom. You can see 1, 2, 3, 4, 5, and 6 carbon is there. Like that 1, 2, 3, 4, 5, 6 oxygen is there. Like 12 hydrogen are there. So that is polyatomic, like lots of atoms are there to form one molecule of glucose. Now I'll see, if we know molecule and compound, how we'll write its formula. So what is chemical formula actually? Describing a molecule in the form of symbols and valency. Simple. If we write its symbol and its valency, so that is called chemical formula. Just symbol, not complete name. So a chemical formula shows what kind of elements are present in the atoms by its symbols, and what a number of atoms are present in of each element, that is from valencies. Like this is molecule of water. How do we know this is 2 hydrogen and 1 oxygen? So with the formula, like we always write H2O, like 2 hydrogen and 1 oxygen. Okay, now we'll see here how can we write chemical formula. First of all, we have to mention symbols, then we have to put subscript. Sub means down, script means anything to write, like the number has to write. So symbols denotes the type of elements, subscript denote the number of atoms. If no subscript, then it means the number of atom is 1. So here we see C in this molecule. Is C is in the center, that is carbon, and 1 2 3 4. How many hydrogen? 4 hydrogen. Write H 4. We don't write 4 here, that is wrong. We always write 4 as a subscript, not the superscript. If we write up, that is superscript, here is subscript, so we write always down. So it means 4 hydrogen are there with 1 carbon. If we see here in this sodium, oxygen and hydrogen. This is from here, you can see here this and this one is one molecule of sodium, hydrogen and oxygen. That is actually called sodium hydroxide. Sodium hydroxide. We'll talk about how we give the name to them, but first write how we write the formula. Because oxygen in the centers, we'll write oxygen in the center and H and sodium at both of the sides. So sodium hydroxide. And we don't write here any subscript because here is hydrogen only one, oxygen only one, sodium only one. That's why we write here 1 1 1, and we don't write 1. There is 1, but we don't write 1 like algebra in the maths. You do that one. How will we make chemical formula of ionic compounds? As we have seen before, when in two elements, one is having positive charge and other is having negative charge, it means that are ionic compounds. Why we know that? One is called cation, this one, and one is called anion, this negative one. That ionic compound is from, for example, sodium chloride or hydrogen chloride, and then magnesium chloride, etc. Because hydrogen loses one electron and chloride gains one electron. Okay, so how do we write formula of ionic compound here? First, we'll give symbol of cation on the left. Cation means which is positive. We'll write on the left side. Like this one is cation here. That is potassium. We write on the left side. Anion we'll write on the right side, like here. How do we know this is cation and anion? You can see the table which we have seen in the previous topic in valency and ions. Ions especially in ions. Now I write valency on lower right side like a subscript of ion after interchanging the crisscross way. Here it's not written, but I have to write here. I write here for your convenience and understanding. Like potassium is having valency +1 and oxygen is having valency -2. We can write at the back also. -2. Now when we write this, we will do crisscross method. Like we'll do in maths also. That's very interesting. Cross multiplication. But here we don't multiply. Actually, we just put from superscript up to the subscript, but on the opposite sides. So now here will be potassium. The 2 will come at the back. We just omit its charges. K2, and O. Why we don't put 1? Because we don't mention 1 as a subscript. We have mentioned O, it means O is in one. Okay, so anion on the right side, cation on the left side, then we'll put valency on both of them, then we do crisscross method, and then we write its formula K2O. It's so easy, isn't it? One thing which I didn't mention here, whenever we write anion, we write in place of Gen-ide. We write ide, like we write chlorine, we write change chlorine into chloride. So we'll write here chloride in place of chlorine. Like oxygen, oxide, hydrogen, hydride. If hydride, H will come here on this side as an anion, so we'll write hydride. Sulfur, sulphide, bromine, bromide. Like that, we'll change this with ide due to its anion. Okay, you can see here formula of ionic compound of some calcium. That is what? Chloride. Yes. So the subscript 1 will not write. We just crisscross here to Ca1 and we write the formula like this: CaCl2. If we write the formula of aluminium chloride, so Al is having +3 valency and this is having -1 valency. When we crisscross, we'll write Al. Al come with 1, so we don't mention here 1, and Cl 3. So this is called aluminium chloride because chloride is anion. Okay, one more thing here. So how we pronounce our formula? Like we can write we can pronounce AlCl3, or we can CaCl2, we can also pronounce like this. If you don't remember its name, calcium chloride, we can also pronounce CaCl2. Like we can pronounce it water, but if we don't know it's like a hydrogen oxide, we can also say hydrogen oxide, but it's easy to pronounce H2O. And this can be C12H22 because this is a long one, so we cannot remember its name. So we write Ce12H22O11. That is the formula of sucrose, sugar, which we eat. Sucrose. Here is the same silver sulphide. So sulfur, because this is here negative charge, so that is anion. So we just crisscross its valencies and we write the formula Ag2S. Ag2S we can also pronounce. We can also say silver sulphide. Dear students, today's and this chapter's last topic is the law of constant composition. Composition means to make, to form. Constant means same. When the molecules or compounds are formed, they are always in constant composition, regardless how compound was made or obtained, from which sources the compounds we get. The same formula is there. They are having the same ratio. They are having the same amount of atoms in that formula. Like, okay, so we'll see this in the next slide. That is presented by French scientist Joseph Proust in late 1700, and he studied about the chemical compounds, and he presented the law of constant composition. In chemistry, we also say it law of definite proportion. Means we just take the ratio, but always molecules or compounds are in the same ratio. For example, if we talk about water, so from where we get water, from river, from oceans, or drinking water from anywhere, its formula is H2O. H2O means two hydrogen and one oxygen. Two hydrogen and one oxygen. So its formula is H2O. From anywhere we get. So we can write its hydrogen is in 2 ratio and oxygen is in 1. So it is 2 ratio 1 always. It can never be changed. So if we talk about the carbon dioxide, so we'll see that its ratio is 1 ratio 2, like 1 carbon and 2 oxygen atoms. So always it is 1 ratio 2. We cannot write it CO. This is not carbon dioxide gas. This is carbon monoxide. That when we change the ratio, its chemical properties are changed. Carbon dioxide, we inhale with the air, but we exhale also. It is present in our body and it is released outside. But carbon monoxide, this is ratio 1 carbon ratio to 1 oxygen ratio. That is very, very harmful and dangerous for our body. Although it does not have, sometimes we don't feel it, but more quantity of this in the body that destroy our cells, and we can even die in within no time. So if we change the ratio, all the chemical properties will be changed, and that is another compound, not this one, not the same one. So it means they are going through the law of constant proportion concept. From where we get that, wherever the source is, that is the law, law of constant proportion is applied on all the compounds. Otherwise the proportions or ratios will be changed, so the chemical compound will be changed. Okay, dear students, let's review of this lesson. We have seen about atoms, its structure, and its mass number and its atomic number. Then we have seen electrons and the shells. We have seen valency and anion. Then we have seen about cations and anions. Then we we took a look on the isotopes in this chapter, as well as its use in medicines and industries and agriculture. Then we have seen today about chemical formula, how it is formed and made, about symbols and valencies, and then in the last we have seen law of constant composition, through which all the compounds are going on. So dear students, that's it for this chapter, and we have finished our 6 chapters of the first term or the midterm. Keep revising all the lessons which we have done, and take care of yourself and your family, and wish you good luck for your future. Allah Hafiz.